Okay, today I need you to focus today. I really need your brain power focused today. It's not going to be difficult when you get to your assignment, but I'm going to do a lot of content that isn't going to be on your assignment, but is going to be important for you to understand. So really try to follow along with me this front part. Very important because we're going to build off of these ideas later on. Okay? I want to look at inverse trig functions. And so the sine function is y equals the sine of x, whereas arcsine function is y equals sine inverse of x. Okay? Sine inverse is referred to as arcsine. When do we use sine inverse or arcsine? You've used it before. You've typed it in your calculator. What were we trying to find when we did that? An angle. When you're solving for an angle, then you use this. Okay? If you're taking sine of an angle, you use that. So when we looked at our sine function, we got a graph that looks something like this. What is the domain of that graph? What kind of numbers can you plug in? All reals. So from negative infinity to positive infinity. What kind of values can you get out when you take the sine of something? Think about the wave. What's the highest you could go for the y and the lowest you could go for the y? For just normal sine. What is the amplitude? 1. So the range goes from -1 up to +1. Sine oscillates between those two values. So what arcsine does, when you do inverses, they change x and y values. So this domain, or this range, goes over the domain. So we want to look at the function over the given domain from -1 to +1. You tell me, sine of what gives you +1? Sine of what gives you +1? 90 degrees or pi over 2? Pi over 2. Sine of what gives us -1? Negative pi over 2. You don't have to know this for your assignment. Just kind of follow how we're generating these values. And then sine of 0 gives you 0. So that's what it looks like. That's what the graph looks like. And it stops there. It doesn't continue to go on. Because if you remember, in order to figure out an inverse function, we take the graph and we flip it over the line y equals x. If you did that, you would get this shape. Why is that not a function? Doesn't pass the vertical line test. And so we can't draw all that. We can't continue to repeat ourselves because it wouldn't pass the vertical line test. So we have to stop there. So we have the domain from -1 to 1, but now what's the range? Because that's been changed. What's the range here? What's the smallest y value and the biggest y value? Yep, from negative pi over 2 to positive pi over 2. If you remember, the cosine function looks something like this. And what's the domain of the cosine function? Very good, all real numbers. Negative infinity to positive infinity. It covers all x values. It continues going on forever to negative infinity and positive infinity. The range. Oh yeah, sorry. You can't achieve positive and negative infinity. Sorry about that. The range would be from -1 to +1. Okay. Well, if we do the same thing that we did to arc sine, if we take the same thing we did to arc sine and do that for arc cosine, we get a little bit different result. And the result looks a little bit like this. Make sure I draw it correctly. I stepped my notes down. I'll have to draw that in there. There we go. That's what you get for arc cosine. You won't have to produce these at all. I just want you to see the graph. If you ever dealt with these, you would see them maybe in calculus. We haven't seen them yet, so I wouldn't worry about it. In calculus too, you might see them a little bit. But the fact is that that's the shape that we get. And if you want to know why, well, you'd say cosine of what value gives you -1? Well, cosine of pi is -1. Cosine of what gives you +1? Cosine of 0 gives you +1. And so you can map it like that. So really the domain, if you look at this, the domain value, again, is from -1 to +1, and the range value is from 0 to pi. This is where you really got to start racking your brain, okay? Look at that. Can I take the sine inverse of +3? No, it's not in the domain. Sine never obtains a value of +3. I cannot take the sine inverse of +3. The most important thing about this graph is for you to understand that these are functions. And so they only obtain certain values for the domain as well as the range. And that you can't take sine inverse or cosine inverse of values outside of those domains. So remember, sine always stays between +1 and -1. Arctangent looks like this. Does that look kind of familiar? Just flipped upside down. What's the domain of that? Domain is all real numbers again. The range can't be equal to -pi/2 or pi/2, but it approaches it. The graph technically approaches these horizontal asymptotes. Now, if we had an unlimited amount of time, we would graph those just like we graph sine, cosine, and tangent and everything else. But it's not that necessary. It's not that much different, so we're not going to do that. I'm going to skip arc cosecant and arc secant because I don't think it's important to our study for today. But arc cotangent does this. Kind of does that. So what's the domain of that? All real numbers again, from -infinity to +infinity. And the range goes from 0 to pi. At this point, I need you to take out your sheet that looks like this, and I need you to take out your calculator, okay? Now, look at this sheet right here. Our first question says, find sine inverse of 1/2. As you look at this sheet, can you give me two angles where we know sine is equal to 1/2? Look at this sheet, two angles where sine is equal to 1/2. Sine of 150 and sine of 30 is equal to 1/2. But when you do sine inverse of 1/2, you can't come up with 150. You know why? Watch. Look at my graph. This is the number one most important part that you have to focus through today, and then we will get to just easy piddly stuff. Watch. Okay, as I take this line right here, I'm going to look at my arc sine function right here, okay? And I'm trying to find the arc sine of 1/2, okay? The arc sine of 1/2. Okay? As I move that across here, as I go to 1/2, see that? The function has a value right there, which is below pi over 2. How much is pi over 2? 90. So you can see that I get, at about 30 degrees right there. It doesn't come up with 150 because it wouldn't be a function anymore if it carried on in that way. So when you look at your sheet, you can't list 150. You have to list the number that's between negative and 90 and positive 90. Well, that's only one, and that value is 30. Your calculator knows how to do it. If you take out your calculator and you go to mode and you are working in degrees, simply just go sine inverse of 0.5, and you will get that 30 degrees. So for these problems, all we need to do is go to our calculator. However, I want you to understand that sine can equal 1/2 in more than one spot. But for arc sine, we only get one result. And in this case, we get 30 degrees. I'm going to write down another problem below it. Sine inverse of negative 1/2. Look on your sheet. How many places is sine equal to negative 1/2? 2. What are those values? 210 and 330 degrees. Now look at this, you guys. 210 and 330 degrees. Are either one of those between negative 90 and positive 90? No. So let's try it on our calculator. What does it give us? If we go sine inverse of negative 0.5, it gives us negative 30. Negative 30 is between 90 and negative 90. In fact, negative 30 is in the exact same position as one of these angles. Is negative 30 degrees in the same position as 210 or 330? Yeah, so those really are the same angles. So I'm just saying your calculator can't come up with all these different ones that you see on your sheet. And you got to understand that. It comes up with the ones that relate to the function that we've shown up on the board. Tangent inverse of negative 1. Look on your sheet. How many places is tangent equal to negative 1? 135 degrees, right? And 315. Well, if you look at arctangent up here, it says that we have to get a value between negative 90 degrees and positive 90 degrees. So neither one of these fit that spot. If you go to your calculator and you go second tangent inverse of negative 1, you get a negative 45. Which one does that match up with? Yeah. So negative 45 degrees is actually the correct answer, though. I mean, that's what we want. Yes, it is in the same position as 315, but negative 45 is the correct answer. A for the day. What's going to be the cosine inverse of 3? The arc cosine of 3. Why? Because cosine can only take on values between positive 1 and negative 1. So very good. It is undefined. And then cosine inverse of the negative square root of 3 over 2. Whoop. I get 150. If you look at cosine, if you look at arc cosine, it always stays above the x-axis. You never get a negative result. You never get a negative result. So for those, you're always going to stay up there. So what I'm telling you is this. All you got to do is punch it in your calculator. All you got to do is punch it in your calculator. Is that difficult? No. But I want you to understand that that doesn't always match up with what we have on our sheet. Does it make sense why they don't match up? Because arc sine, arc cosine, those are functions, and they're more specific on what values they can generate, okay? Let's go to the back side. The first example that we do will appear somewhat confusing, and then it's going to be very easy after that. So just watch your way through it, and then trust me, you'll get it. That's what happened second hour, and that's what I anticipated. Now it says evaluate the expression by sketching a triangle. We want to find the sine of cosine inverse of 1/2. Well, first of all, I'm going to suggest that cosine inverse of 1/2, what that means is cosine of some angle is equal to what? 1/2. Cosine inverse of 1/2, or arc cosine of 1/2, means what angle do I take the cosine of to get 1/2? So, yeah, you're right. It is 60. I'm not going to use 60. I don't need to in the problem, but I'm going to rewrite this. I'm going to sketch a triangle with opposite, adjacent, and hypotenuse to be able to figure out the sine piece here. What is cosine in terms of opposite, adjacent, and hypotenuse? Adjacent over hypotenuse. We got to remember that. So I draw my triangle, and I'm just going to put an angle wherever I want. That's the angle I'm referring to in the problem. What is the length of the adjacent side? 1. What's the length of the hypotenuse? 2. How do I come up with the length of the opposite side then? Use the Pythagorean theorem. So 1 squared plus x squared is equal to 4 squared. I'm sorry, 2 squared. Or 1 plus x squared is equal to 4. X squared is equal to 3. So this is the square root of 3. So I've drawn my triangle. Now, this is the million-dollar question. If I take cosine inverse of 1/2, what do I get? I get an angle, right? I get theta. So I can replace this thing. I know that this thing right there is just theta, right? So really what I'm trying to find is sine of theta. What is the sine of theta in this problem? Square root of 3 over 2. Jalen went to the opposite divided by the hypotenuse. So this was really asking what is the sine of theta in this problem, and sine is opposite divided by hypotenuse, square root of 3 over 2. That's your answer. We'll do the next one together. You can do the C and D on your own. Can you do it without it? Levi, if you can do it without doing a triangle, go ahead. But I will teach it with a triangle. Okay. So sine is equal to opposite over hypotenuse. So what's the length of my opposite side? 4. Hypotenuse. 8 for the day. What's the other side? 3. How do you know that? Special right triangle, 3, 4, 5. So really this question is asking, if I take the sine inverse, what do I get? I get the angle, whatever that thing is. So really this question is asking, what is the cotangent of theta? What's the cotangent of theta? Well, cotangent is what? Opposite over adjacent, adjacent over opposite. What is it? Adjacent over opposite, which is equal to 3/4. Piece of cake, upside down. You try C and D. Okay, guys, Sam's finishing up here. It looks like Jalen got 13 over 5 for part D, and then for part C, Sam got 2 square roots of 2. Is that what you got? If you didn't, then raise your hand. I'll come around and see you, and I'll help you figure that out. But that's what you do. So our 2 objectives for today is the study of arc sine, arc cosine, arc trig functions is very involved. And I just try to cover a brief portion of it. But really what we want to do is come up with the correct values when we do sine inverse and tangent inverse and stuff like that. Understand where values are undefined if they're not in the domain. And then finally, be able to sketch triangles and understand the nature of what that's doing, okay? And your assignment is right here. Have a great day.